Sometimes you'll be asked, what are the factors which determines factor affecting the value of the core option? So what are those factors that are affecting the value of the core option? Whenever you ask about the factor affecting the value of the core option, what comes to your mind? You don't have to cram them. Just get the formula correct. This formula, everything you see here, those are the factors affecting the value. Like you can say the market price per share, the exercise price, the risk-free rate, time to maturity, the variance or the standard deviation. So now those are the factors which affects the value of the call. Also, you may be asked to get the limit. What are the limitations of using Brack and score model? If you have the assumption, you just convert them into limitation, because assumption in layman's language, that means they are just the limitation. Because number one, it says that the risk-free rate is constant, but do you expect the rate always to be constant? So you can say, you say the assumptions. I want to show you how to convert the assumption into limitation. Now, it assumes that the risk-free rate is constant. How is that a limitation? So in practice, you don't expect the rate to be always be constant during the period. Another thing, it assumes that an option is always an European option. So that means you cannot use this model to value any other model. For example, in American or Bermudian option. Also, another characteristic was that it assumes there is no penalty or no restriction. But in every market, there must be penalty. Also, it assumes there is no transaction cost. In every business, there must be transaction cost. I'm trying to show you how to convert the assumption into limitations. So kindly now, let's do an illustration. Let's do our first illustration. June 2010. June 2010. June 2010, question 5B. June 2010, question 5B. So now, let's start with question 5B part 1. B part 1. Explain the key factor that affect the value of the option. Jogona?
Yes.
Give me one of the factors which affect the value of the option.
The value of the option, it is the price.
The price, the market price per share?
Yeah, the market price, the rate, the exercise.
Usiseme zote. Now, let's go to Elizabeth. Eliza? Okay, sawa. That's good. Sharon, do you have any? Okay. Yeah, now those are some of the factors which affect the value of the call. We have said that you just go to the formula. The market price per share, the exercise price, the time to maturity, also the risk-free rate, those are the factors. Now let's go back. Okay. Yeah, now those are some of the factors which affect the value of the call. We have said that you just go to the formula. The market price per share, the exercise price, the time to maturity, also the risk-free rate, those are the factors. Now let's go back. Let's jump to part C. Jump to part C. So now, part C, outline 4 limitations of Brack and score option pricing model. Remember, you have said the limitation. You just take the assumption. You just convert them. Now, let's go to objective. Part B, part 2. Part 2, we are told that Mapema Limited share are currently trading at 3.5. That's the market price per share. That means the MPS is 3.5. A European call option exists on the share with an exercise price of 3.3. That means our E is 3.3. Also, we are told that with an exercise price of 3.3 with 3 months to maturity. 3 months to maturity. So 3 months to maturity, what does that mean? That means that our T, if it's 3 months, we have said that T is time remaining to maturity in years. So you just take 3 divided by 12, it will get 0.25. Also, the risk-free rate is 8%, R is 8%, and the variance of the return of the shares is 12%. The variance, that's standard deviation is quite 0.12. Required, determine the value of the core option using Brack and score option pricing model. How to determine that? Now let's come back. So now let's get the value of the call. Let's get the value of the call. We have said that the value of the call, you take P ND1 minus E raised power RT ND2. And how do we get D1? This is how we get D1. D1, we have said that you take the natural log P, or the market price per share, over the exercise price. You add the risk-free rate plus a half standard deviation squared. Then you multiply by T, time remaining to maturity. Then you divide by standard deviation square root of T. Then, how do we get D2? D2 is D1 minus standard deviation square root of T. So now let's elaborate that. You take your natural log P, our market price per share was 3.5. You take 3.5, then you divide by the exercise price. If the exercise price was 3.3, then you add R, the risk-free rate was 8%. That means it will be 0.08. You add a half, that's 0.5 standard deviation square. Now that means the variance. How do you get the variance was 12%? You multiply by 0.12. Then all of it you multiply by T. Time remaining to maturity was 3 months. So you convert it into years. So it's 3 over 12, which is 0.25. 0.25. So how much do you get from that? So using my calculator, also all of it you divide by the standard deviation. Now in this case, we are given the variance 0.12. So you take 0.12, but remember this is the variance. We want the standard deviation. So you get the square root. Then you multiply by square root of T. Get square root of T, which is 0.25. So now this is how we compute. This is how we compute. So first of all, you apply the rules of BODMAS. So in this case, you take 0.5, you multiply by 0.12, then you add 0.08, 0.08, then you multiply by 0.25, then you add, first of all, you put the natural log. This is the natural log. We want to put this. You put the natural log, then you open the bracket. From there, now you take 3.5, you divide by 3.3, then you close the bracket, equals. Then you divide by, you open the bracket. We are dealing now with this. Square root of 0.12, you multiply by square root of 0.25, close the bracket. And you get 0.54. So when you're getting this, kind of always be using a two decimal places. So this one you get 0.54. Now let's go to D2. D2, you take D1, of which we have 0.54 minus standard deviation. It is 0.12. That was the variance. Then you get square root for you to get the standard deviation. Then you multiply by square root of T, square root of 0.25. So this is what you do. You just take 0.54, what you have gotten, minus, just open the bracket, square root of 0.12, you multiply by square root of 0.25, close the bracket. With that, you get 0.3. We have said that always round off to two decimal places, so it will be 0.37. Good. So when you have D1 and you have D2, what we need now is how to get ND1. How do we get ND2? ND1, ND2. From the formula, remember we said that it's ND1, ND2. So N means the normal distribution. So I want you to get this concept. If you get the value of D1 and D2, they are positive. So that means you take 0.5, 0.5, you add. I repeat again. If you get a positive number from D1 and D2, when you're getting the ends, the normal distribution, you take 0.5, you add. Now, let's go back to D1. How much was D1? It was 0.54. How do we get the normal distribution? So we have this table. This is just the normal curve. So if you want to get 0.54, this 0.54, this I read it, 0.5, you go to 4, which is 0.2051. So that means you add 0.2051. I repeat again. If you want to get 0.54, that's D1. We are converting this D1, which is 0.54, into N. N means the normal distribution. So you just take 0.5. I'll come to explain why do we add 0.5. Then to get 0.54, you just come here, 0.5, 0.54. Now let's go to D2. Our D2 was 0.37. How do we get 0.37? 0.37, you just come back to the table, 0.3, you go to 7. You get 0.1443, 0.1443. That means our ND1, 0.5, you add 0.2, you get 0.7051. Take 0.5, you add 0.114, you'll get 0.6443. When you get a positive, this is what we mean. Let me take you back to normal distribution. Unachora kaugari hapo. So remember, it's always divided into 2. 0.5, 0.5. If you get 0.54 and 0.37 being positive, that means they are on this side. So that means equal hapo. So that means you have to add all this. You get this, which was 0.25, and then you add the remaining half. If it was a negative, negative means it's on the lower side. You could have deducted. Assuming it was negative 0.54, you could have taken 0.5 minus 0.2051. Now, with the ND1 and ND2, now we can get the value of the call. We go back to this formula. We have said you take P. P is the market price per share, of which it was 3.5. You multiply by ND1, and ND1, it's 0.7051, minus E. The exercise price was 3.3. You divide by E, that's the exponential, which is 2.7183. If you use a calculator, this is what we call E. You press shift and then the natural log, you get E. Then you can press 1, then equals. You get 2.7183. Raised to power RT, our risk-free rate was 8. However, it will be raised by 0.08. You multiply by T. Time to maturity was 0.25. That's 3/12. Then out of it, you multiply by ND2. And our ND2, you'll get 0.6443. Let me repeat again. I can see someone asking, I repeat on how to get the D1 and D2. I'm saying that for ND1 and ND2, N means the normal distribution. That means you need to use this, the normal curve, the normal curve. And we have said that if you get a positive, if D1 and D2 were positive, yeah. If you get, this is what I mean. If you get D1 and D2 as positive, that means you take 0.5, you add that. For example, in this case, our D1 was 0.54. So just come here, you take 0.5, you go to 4. You'll get 0.2051. 2051. D2, you do the same. For D2, we had 0.37. Using the normal curve, you just come 0.3, then you go to 7. You get 0.1443. So just take 0.5, you add 0.1443, and that is it. So now let's get the value of the call. Now, I'm sure up to this level, if I give you an opportunity to compute this, most of you will get a wrong figure. So in this case, kindly, when you're doing bracket and score, apply the rule of body mass. This is what you do. Either see how I'll be computing. See how I'll be computing. You just start with the denominator here. You just take 2.7183 raised to power. You just open the bracket. You open the bracket. 0.08, you multiply by 0.25, you just close the bracket, you get the denominator. Then I take 3.3, I divide by the answer. So that means I have this divided by this. Then you multiply by 0.6443. 0.6443. You get that. Then you want to get this. You can just open the bracket directly. Open the bracket. You take 3.5. 3.5, you multiply by 0.7051. I close the bracket. I close the bracket, and then I minus the answer. And you get 0.38. 0.3838. So that's how we get the value of the call. Now, assuming the examiner also wanted the value of the put, using bracket and score, using the value of the put, you just use the put call parity theorem. I repeat again. In this case, just want it was just a core option. In case the examiner wanted the value of the put, this will get the value of the put. You use the put call parity theorem. We say that P is equals to C minus PA plus PE exponential ER, sorry, or you can just use this one as E. E and then small e raised to power negative RT. That is when you wanted to get the value